Okay, in this video we're going to talk about how to find the average rate of change of a function. And the average rate of change is just a fancy way of asking you what is the slope of a curve over a given interval. Now, we're going to look at some graphs and we're going to look at some functions here that are not linear equations. They're not our usual y equals mx plus b. These curves, they might in fact be curves instead of straight lines, and they might actually have some exponents involved for the x, but the process to finding this average rate of change is always the same. You're going to find the slope between two coordinates. So let's look here at this first problem. Let's find the average rate of change of f, which is the graph given below. So this graph here on the interval from -8 to 2. So basically, what I need to do is I need to go to my graph, since I have it, and I'm going to go put a dot on the graph at -8. And I'm going to write the coordinates. So at -8, we have an x value of -8, and the y value of that is 2. So I got a point, -8, comma 2. And then we're going to go to 2 here. We're going to do the same thing. So I'm going to 2. I'm going to go put a dot there. And I'm going to go look at the coordinate. So it has an x value of 2, has a y value of 12. Make sure you're careful counting grid blocks. You want to pay attention to the scale of the graph. And so I have my 2 points. Now, average rate of change is nothing more than your slope formula. So I label my coordinates x1, y1, x2, y2, and then we use our slope formula. So m equals y2 minus y1 over x2 minus x1. We put our numbers in where they go. So it'd be 12 minus 2 over 2 minus -8. And that gives us 10 on top and 10 on the bottom. So the average rate of change of this function is equal to 1. Now let's try to find the same thing. I want to find the average rate of change, but instead of giving you a graph, we have a table here. So we want to find the average rate of change over the interval from 4 to 6. So what I'm going to do is to find that, I'm going to look at my endpoints at 4 and at 6. I'm going to go to my table where x is 4, and I'm going to circle that x and then its output value. So I got 4, 10. I'm going to write it as a point. And then I go to 6, I do the same thing. So 6, I'm going to circle it and its y value of 40. So I got 4 by 10, and I got 6 by 40. Well, since we're looking for average rate of change, which is the same thing as the slope, we're going to use our slope formula. So I got x1, y1, x2, y2, and use our slope form. It says the slope of a line that passes through 2 points is y2 minus y1 over x2 minus x1. Plug in our numbers. So y2 is 40 minus y1 is 10 over x2 is 6 minus x1 is 4. And that gives us 30 over 2. We have our average rate of change. 30 over 2 is 15. And the last kind of question you could see regarding the average rate of change is we're given just the equation of the function. We don't have the graph and we don't have the table. So we still want to find the average rate of change, which is the slope. And I'm given the interval here, so from -1 to 5, but all I have to work with is the equation. So when you're given the equation, what you need to do is I need to get the y values. So I need to put -1 in. I always use the endpoints when I'm finding the average rate of change. So I'm going to put -1 into my function. So I put it in where the x's are. And then I evaluate PEMDAS. So -1 squared is 1. I got plus 2, minus 2. And so I get an answer here of f of -1 is 1. All right, so I'm going to need that in just a second. Then I need to do the same thing for 5. So I'm going to put 5 in for x's. So I got 5 squared minus 2 times 5 minus 2. So that is 25 minus 10 minus 2. 25 minus 10 is 15. Minus another 2 is 13. So I got the y values. Now what we're going to do is, just so we don't further complicate anything, we're going to write these things as coordinates. So I got one coordinate that has an x value of -1. I got another coordinate that has an x value of 5. Well, what we just did was we found the y values. So the y value of -1 is +1. The y value of 5 is 13. So to find the average rate of change, which is our slope, we're going to identify those numbers as x1, y1, x2, y2, and we're going to use our slope formula. So the slope of the line, or the average rate of change, y2 minus y1 over x2 minus x1, I go put the numbers in, would be 13 minus 1 over 5 minus -1, and that's going to give us 12 on top, 6 on the bottom, so the average rate of change is 2.